Hello everyone. So today we are going to learn a very important topic which is switch debouncing. This is a very important concept in the embedded system. I should say that the one who are designing embedded system or some sort of microcontroller based circuit where you are interfacing relays, mechanical switch, push button, then this concept will be very important to apply there. So let's study and try to understand what are the switch bouncing, what are the ways to remove the switch bouncing, what is switch debouncing, what are the different circuits that can remove the switch bouncing. So let's first try to understand what is switch bouncing. So just to give you a definition of switch bouncing, what it is. So switch bouncing is the non-ideal behavior. So when I say non-ideal behavior, so switch bouncing you don't want, right? We as a engineer, uh, we don't want the switch to be bounce. So that is why I'm calling it as a non-ideal behavior. So switch bouncing is a non-ideal behavior where there is a multiple transition. There is a multiple transition for a single user input. So you are a user and then there is a push button, and when you are pressing this push button a single time, there is a multiple transition before it reaches to a stable state. So that is called switch bouncing. Let's take one example. Just take an example of a bouncing ball. So when it drops on the ground, right? When it drops on the ground, so before it comes to a rest, right? It bounces back and then again it bounces back to ground. So there is some, it takes some time to come to a rest. So that we can take as a example to understand this switch bouncing phenomenon. So think of so we have a switch, right? We have one switch. So think it like when a switch touches the ground, it is same as a closed circuit, and when the switch bounces back, it is similar to switch open. So what is happening is there is a multiple breaking and closing of a circuit. So that is causing a multiple transition before it reaches to a stable state. So that is a switch bouncing. And what is the impact of this switch bouncing? So let's suppose this switch you have connected to a microcontroller pin, right? You have connected to a microcontroller pin. Then when you press it, right, this microcontroller will sense multiple inputs, 1 0, within a very limited time period. So it will not detect a proper logic level. That is why it will give you a invalid uh, output. So that is not good to have. So we want switch not to be bounced. So for that we have a method called switch debouncing, wherein we apply some method to remove this multiple transition. So there are different ways wherein you can apply to remove this switch bouncing. First is a hardware debouncing. So the first we'll try to understand this hardware debouncing, and then second you use a RC circuit. So you use a RC circuit, and then there is the third is software debouncing. But software debouncing will not cover in this session. So if required, then please comment. So I will cover in the next session. As of today, we'll just try to cover this hardware debouncing and RC circuit. So you can see this circuit over here, which I have already drawn. Uh, so you can see, right? This you can remember from my SR latch and flip flop session. So this is a SR NAND latch which I have connected to the input of my switch. And what I want is when I press the switch, even though there is a multiple transition, but my output remains same. So it latches or go into the latch state. So that is my that is my motive. So you see, right? I have connected one input of this upper NAND gate with the pull-up resistor to 5 volt, and here this is my SPDT switch, and this is connected to the lower pull-up, okay, to one of the lower NAND gate, right? So when you see my the logic, the waveform of B, so it is high, okay, and then I am considering that there is a multiple transition. So when you switch this from position A to B, then this B becomes low, and there is a multiple transition before coming to low. So this is representing that. And A, as you can see, it is at a low state, and then when it moves back to position B, right, and it becomes 1, right, and from B to A when it comes, so before it settle down there is a multiple transition which I have represented over here. Now I want my output like this, right? There is no any multiple transition or there is no any fluctuation. I don't want that. So you can see, right? So this consider this schematic. So this is my 0, okay, logic 0. It is connected to ground, logic 0. So this is a NAND gate. It will become 1, right? And this is connected to a pull up. So this is 1, and then this is my feedback over here, this is 1, so this is NAND gate, it becomes 0, right? Now you switch back from position A to B, right? A to B. So what it will be, so this part, this will be 0, okay, from 1 it will become 0. Now since we NAND gate, it will be 1, right? So 1 will come over here, and now when it has gone to B position, this is pull up, right? So this becomes 1, right? And then it becomes 0. So now we have a 1, and the switch is at B. So even there is a multiple fluctuation, right? Even there is a multiple fluctuation because there is a feedback 0 over here, right? There is a feedback 0 over here. It will always be 1. There is, it will not change its states. So that is one very good example of this hardware debouncing, because you have a 0 as a feedback, right? So even though this changes 1 to 0, but the output will remain same, 1. So that is why you see 0 and then 1. So it will always remain same. So this is hardware debouncing, and this is a common circuit that is used for hardware debouncing. One of the disadvantage it is here is that you see, right, this is a bulky circuit, right? You are using a SR NAND latch, and then there is a SPDT relay which is a costlier. That is why it is not used most in the circuit. So we'll try to cover this RC circuit, okay? So what I have done is I have just taken a similar circuit, okay, but the relay is SPAST. So this is my similar circuit, and then the output I have connected to a RC filter. Okay, this is my RC filter. So what capacitor will do? Capacitor will prevent these quick changes in the switch signal. Okay, so it will prevent that quick changes. So let's understand. Let's suppose, and this is my inverter. Okay, inverter circuit. You can take as a schematic trigger inverter, and it will also prevent hysteresis. That is why you can use that. And let's understand, so when there is a, the circuit is open, right? Circuit is open, so the voltage, so this capacitor will charge through this R1 and R2, and when it reaches VCC, right, so this inverter will sense it as a logic high, so the output will be 0, right? But when you switch back, right, when you switch back, So what will happen? The capacitor will be connected to ground. So it will discharge through this R2, okay, and then it will be 0, and so you have a output as a 1. Now you might be thinking where the switch bouncing is coming. So let's understand. So when this switch will collide, right, or there will be switch bouncing. So what will happen? The capacitor will hold the voltage when it reaches either VCC or ground. So it will hold the voltage, and then the output will remain stable. And that is how you can control this switch bouncing. So this is also a very important topic. But you will see that these both hardware debouncing and RC circuit, this is used mostly in the embedded system where there is a mechanical relay switch or the microcontroller interfacing. But it is not used in the power system or power electronics. It is not required. But you will see mostly this is very important to be applied in the embedded system. So thank you, and please comment you have if you have any query or if you like this topic, please comment.